In the video about single loop circuits, we have discussed how to write equations for a loop using Kirchhoff's law and how to solve it to find the current in the circuit. Now in this video, we're going to deal with circuits with multiple loops in it. For example, in this problem, we have three resistors R1, R2 and R3. R1 is 10 ohm, R2 is 40 ohms, R3 is 10 ohms. Two voltage sources, 6 volt and 12 volt. And we have multiple loops in this problem. This is the first loop, this is the second loop, and this is the third loop. So we need multiple equations using Kirchhoff's laws. I'm going to assign direction for the current. So this battery is facing up. This is the positive terminal of this battery. So current is flowing upwards. This current is flowing through resistor R1. Let's call it I1. For this battery, this is the positive terminal. So the current is flowing up. And the same current is flowing through resistor R2. Let's call it I2. So I1 is coming to this junction. It is also coming to this junction. And they would flow together downwards. Let's call it I3 because it's flowing through R3. We need to find the value of all these currents, I1, I2 and I3. We have three unknown variables, so we need at least three equations to solve this problem. And let's say you choose the wrong direction for the current, you'll still get the same answer but with a negative sign. So I'm going to apply Kirchhoff's laws here. So I need at least three equations. I'm going to write equation for this loop using Kirchhoff's voltage rule. Let's call it L1. I'm going clockwise in this loop. Okay, let's write the equation for this loop. We need to mark signs for the components before that. This is the positive terminal of the battery, negative terminal of the battery. Current is flowing from left to right. So this is plus, minus. Current is flowing downwards, so plus, minus. Current is flowing from right to left, so plus, minus. This is positive and this is negative. Okay, so I'm considering loop 1. It's a clockwise loop. I'm going to start from VA, going clockwise, just like this. So minus to plus is plus. Plus VA, we are here. Plus to minus is minus. It's a drop. The voltage here is current times resistance, I1 R1. We are here, plus to minus is a drop again. Voltage here is I3 R3 equals 0. VA is 6 volt, I1 is unknown, R1 is 10, so 10 I1 minus R3 is 10 again, I3 is unknown, equal to 0. Let's call it equation number 1. This is the equation for loop number 1. Let's write the equation for loop number 2. Loop 2. Okay, so I'm choosing this loop as the second loop. I'm gonna go counterclockwise this time in this loop. Just to show you, it doesn't make any difference. You can choose any direction, either clockwise or counterclockwise. It's totally fine. Yes. So this is my loop 2. And I'm choosing a counterclockwise loop, L2. I'm going to start from VB. We're going counterclockwise, just like this. So we're going from minus to plus, which is an increase. So minus to plus is plus VB. We're going this way. Plus to minus is minus. Minus voltage here is I2 R2. Plus to minus is a drop again, I3 R3 is equal to 0. Kirchhoff's voltage rule. VB is 12 volt minus 40 I2, R2 is 40, I2 is unknown, minus R3 is 10 I3 is unknown is equal to 0. I'm going to call it equation number 2. We have two equations, but we have three unknown variables. We have I1 here, I3 here, I2 here, I3 here. I'm going to write one more equation, but this time I'm going to use junction rule. Okay. There are two junctions in this circuit. This is the first junction, J1. I'm going to write equation for that junction. For J1, junction 1, total incoming current should be equal to total outgoing current. I1 and I2 are coming towards the junction. So I1 plus I2 is equal to I3 is leaving the junction. It's equal to I3. This is equation number 3. I can replace I3 in equation number 1 and equation number 2 with I1 plus I2. But if you do that, you need to change both the equations. Okay, but if you find I1 from this equation, let's say I1 equals I3 minus I2, then you need to change only equation number 1. You can write equation for I2 as well. I2 equals I3 minus I1, and then you can go ahead and change equation number 2. Okay, replace I2 with I3 minus I1. That would work as well. It's up to you. Okay, so that's my equation. I1 equals I3 minus I2. Let's call it equation number 4. I'm going to substitute equation number 4, substituting equation number 4 in equation number 1. I'm going to replace I1. That will make it a two variable problem. So 6 minus 10 I1. I1 is I3 minus I2, right? I'm going to replace I1 with I3 minus I2. I3 minus I2 minus 10 I3 equals 0. 6 minus 10 into I3 minus 10 I3 minus 10 into minus I2 plus 10 I2 minus 10 I3 equals 0. 6 minus 10 I3 and minus 10 I3 minus 20 I3 plus 10 I2 equals 0. Let's call it equation number 5. So we have a modified version of equation number 1, that is 6 minus 20 I3 plus 10 I2 equals 0. So we don't need equation number 1 anymore. But we need equation number 2. I'm going to write equation number 2. 12 minus 40 I2 minus 10 I3 equals 0. We have two unknown variables, I2 and I3, and we have two equations, equation number 5 and equation number 2. I'm going to use elimination method here. We have minus 40 I2 here and plus 10 I2 here. So if you multiply equation number 5 with 4, this will be plus 40 I2. Then if you add these two equations, you can eliminate I2. Or you can multiply equation number 2 with minus 2. That will make this term plus 20 I3. Then if you add these two equations, you can cancel out minus 20 I3 and plus 20 I3. I'm going to multiply equation number 5 with 4. 4 times 6 minus this whole equation with 4. 6 minus 20 I3 plus 10 I2 equals 0. 6 times 4, 24. Minus 20 into 4, minus 80 I3 plus 10 into 4 plus 40 I2 equals 0. That's the modified version of equation number 5. Let's call it equation number 6. And we have equation number 2 as well, which is 12 minus 10 I3 minus 40 I2 equals 0. Just rearranged it. I'm going to add equation number 6 and equation number 2. 24 plus 12, 36. Minus 80 minus 10, minus 90 I3. Plus 40 I2 and minus 40 I2 are gone. 0 plus 0 is 0. Solve for I3. Minus 90 I3 equals minus 36. minus and minus gone, I3 equals 36 over 90, that is equal to 0.4 amps. So we got I3. You can substitute in any one of the equations with I2 and I3. You can solve for I2. Let's call it equation number 7. I'm going to substitute in equation number 2. Substituting equation number 7 in equation number 2. This is equation number 2. 12 minus 40I2 minus 10I3 equals 0. 12 minus 40I2 minus 10 I3 is 0.4. Replace I3 with 0.4 equals 0. Solve for I2. Minus 40I2 equals 4 minus 12. Minus 40I2 equals minus 8. I2 equals minus 8 by minus 40. I2 equals 0.2 amps. Question number 8. We have I2 and I3 now. Let's go to the junction rule. I1 equals I3 minus I2. I'm going to substitute the value of I2 and I3 in equation number 4. So equation number 7, substituting equation number 7 and equation number 8. Value of I3 and I2 in equation number 4. Equation number 4 is I1 equals I3 minus I2. I1 equals I3 minus I2. I3 is 0.4. I2 is 0.2. So I1 equals 0.2. Equation number 9. We found the current flowing through resistor 1, I1, resistor 2, I2, and resistor 3, I3. There is one more question. Calculate the power PA and PB supplied by battery A and by battery B. So battery A is a 6-volt battery and battery B is a 12-volt battery, and we need to find the power supplied by the battery, which is PA and PB. There are 3 different equations for power. P equals VI, P equals I squared R, P equals V squared by R. We have voltage of the battery, VA equals 6 volt and VB equals 12 volt. And we know the current flowing through them. I1 is the current flowing through VA, and we found I1, which is 0.2 amps, and I2 is the current flowing through VB, which is again 0.2 amps. So IA equals 0.2 amps per unit. IB is also 0.2. So PA equals VA IA, voltage is 6 times 0.2, 1.2 watts. PB equals VB times IB, voltage is 12, IB is 0.2, 2.4 watts.